Hi, I'm Elijah Nicpon, and this is the shirt from my freshman year for robotics and TSA. On the back it says that an engineer is someone who solves a problem you didn't know you had in a way that you don't understand. And I don't like it, and that's because an engineer is so much more than that. And every engineer has different experiences that shapes the way that they define an engineer. And for me, that's going to be robotics, research, and outreach. I began robotics in elementary school as part of the first ever team for FLL at my school. And ever since then, my love for robotics has continued to grow. I started VEX as a sophomore in high school and instantly fell in love. Each year, a complex new game challenges teams to use their skills to develop design solutions. My team, Team 1264D, emphasized the engineering design process in our engineering design notebook. The journal includes 3 notebooks, including our design notebook, build notebook, and coding notebook, which includes all of our CAD, all of our build progress, and all of our annotated code. The journal also includes all of our brainstorming for each and every robot. Using the engineering design process, we carefully consider every single option for every single part of our design. Here is our cap and tape for our 2019-2018 game. And pew charts, which determine the viability of each one. Mechanical design drawings, CAD for each of the options, and more. Throughout the year, we referred to this journal, and by taking into account every single unique possibility, I created a unique 6-motor drivetrain that won us the Innovate Award and qualified us for the VEX World Championship. Traveling to Louisville, Kentucky to compete with some of the best teams in the world was an experience that I'll never forget. This year, as co-team captain, I've led my team to an early state qualification spot. We've built 3 robots thus far with the same design and documentation procedures. I also participate in FIRST robotics competition. I lead the media team and document our team's progress while simultaneously helping with the design and fabrication of the robot. Both robotics have not only just helped me learn hands-on skills like designing award-winning drivetrains, but with my communication and leadership as well. While research isn't the first thing that comes to mind when you say the word engineering, my physics teacher was sure to instill its importance to me during physics this year and my science fair. My partner and I sought to answer how superconductivity is affected by magnetic flux in accordance with the Meissner effect, which determined the feasibility of our materials, YBCO, in high-stress situations like those found in ITER, the International Tokamak Experimental Reactor. We formulated an experiment to test resistivity versus temperature versus magnetic flux that would require cryostat, so I reached out to dozens of experts at Georgia Tech. Professor Martin Murigo was kind enough to admit me and my partner into his lab so we can do our research, which we'll present at our regional science fair in February. We found the critical field and critical temperatures for both substances and oscillated them to create a 3D map to understand the mixed state of superconductivity. These values are really important in terms of engineering, because those values are used to make sure reactors can contain plasma and not explode. I've applied the skills I learned in physics and in this research to my own engineering projects with fantastic results. Physics has taught me how to maximize mechanical advantage, and I've learned how important research can be to make the best decision regarding materials. For example, I now not only take into account strength and weight, but mu, the coefficient of friction as well, leading my VEX team to popularize the use of studded Omni wheels for grip in the state of Georgia. And now for outreach. While we never had student mentors at my elementary school, I now recognize what an asset they would have been. And I wanted to help develop a new generation of engineers as best as I could. With the help of my advisor, we founded our Feeder Middle School's very first VEX robotics team. They come to our lab every day we have VEX and help them hone their skills so that they can compete on a higher level when they reach high school and to give them a head start in their careers. Helping them has been such a fulfilling process, and I'm so proud of the improvement they've had this year. They have begun to develop coding, design, documentation, and mechanical skills miles above kids their age. They place in the top half at high school level events, and I couldn't be happier for them. My VEX team also participates in a bunch of other community-related events, including our Feeder Elementary School STEM Night. It was a great opportunity to get more members of the community involved with engineering, and for many kids, it's their first glance into creative new world. That hands-on experience prompted many 5th graders to ask about joining, and we happily directed them to our middle school team. In the past, we've also hosted a girl-powered event and invited elementary and middle schoolers to participate in various engineering games and challenges. Thank you for watching this video, and I hope you enjoyed. Those were my 3 R's for engineering, and thank you for your consideration.